Well, hello, mathematicians. Welcome back. Today we're going to be talking about how to divide fractions by other fractions. We have done previously whole numbers by fractions, but this is the first little excursion we have into dividing fractions by fractions. Before we get started today, I want you to do the hands-on activity on page 70 and in your textbook. And I want you to do specifically the second problem in that hands-on activity. And then we will talk about it. All right. So in class, we have done previously this particular problem. Let's go ahead and model it first. Okay, and we are going to cut this in half. And the question that we were asking was how many, this is 1/2, right? This is, this particular fraction is divided into 1/2 size pieces. Let me shade it in a little bit. The question was, how many fourths are in 1/2? Oops. And in order to do it, we had to be willing to model with this, all right? So let's mark this as 1/4. This piece is 1/4. And if we broke up this side as well, we would see that we have 4 pieces. And this piece that we started off with is 1/2. Okay, and we want to see how many 1/4 size pieces are in 1/2. And I think it's pretty clear that you have, in fact, 2 1/4 size pieces within 1/2. All right, the answer is 2. And so we had a rule that we had made that in order to multiply, or in order to divide fractions, we're going to multiply by the reciprocal. This problem is very easily stated. If we take the 1/2 and instead we're going to multiply by 4/1, all right, we wind up with 4 halves, and we know that that simplifies to 2, all right? So we can get the same answer we get by modeling just by multiplying by the reciprocal. But of course, we want to ask ourselves, what is actually happening here? So you have the 1/2, and you're dividing it by 1/4. And this is a complex fraction, and we don't want the complex fraction to be there. So we're going to multiply the denominator by its reciprocal to get 1, okay? And when I do that, then I have a problem that's 1/2 over 1, 1 being 4/4 in this case. But I can't leave this just having multiplied the denominator by the reciprocal. I have to multiply the numerator by the reciprocal too. Okay, and oops, that's a 1, not a 2. Getting ahead of myself. All right, and when I do that, my new problem is 4 halves, which is 2. All right, so that's how it works. Any way you slice it. Okay, I want you to make sure that you have done on your own the second half of the hands-on activity. And when I flip over the page, hopefully you will have done it. So in this problem, we have 2/3. Very bright pink here to stand out, really stand out. So we have 2/3 shaded, and the problem is asking us, in 2/3, how many 1/6 are there? So maybe you've got the gist of this, right? If you just subdivide your thirds, you come up with sixths, right? And so now that it's divided into sixths, I think each of these pieces is 1/6, right? I think you can see that within 2/3, right, you have, here's another sixth, here's a 1/6, and here's a 1/6, right? There are 4 1/6 in 2/3. Now, does the math check out? Well, of course, we're taking the 2/3. I was just thinking that some of you might make that mistake. And I wound up making it. We need to keep this as a plain 2/3, right? But when we translate this, we're going to be multiplying by the reciprocal, the inverse, right? We're going to be doing an inverse operation with an inverse number. And then, of course, when we multiply across numerator times numerator and denominator times denominator. And so that is going to give us 2 times 6, which is 12, and 3 times 1, which is 3. And when we simplify that, 12 divided by 3 is 4. And that's our answer. Now, we could have simplified this earlier. We had talked about simplifying earlier, and we know that 3 goes into itself once, and it goes into 6 twice. So then our new problem becomes 2 over 1 times 2 over 1, which gives us 4. And we could have skipped this in-between step. Okay, so we see very clearly by just doing this math that it's 4, and we see by counting the number of pieces that it's 4, and we can see by setting our problem up the other way. 2/3 divided by 1/6 in our complex fraction. We're going to eliminate this 1/6, turn it into a 1 by multiplying by the reciprocal. Can't do it just to the bottom, so we have to do it also to the numerator. Okay? And you see here in the numerator that essentially this is the same problem that we just solved over here, right? 2 times 6 being 12, 3 times 1 being 3, and this all over 1, which gives us 4. Okay, let's do another one, shall we? These are fun. Okay, how about this one? What about if we divide a non-unit fraction by a non-unit fraction? And the question is, we have 3/4. How many 3/8 are in 3/4? All right. And to get us started, of course, we have this nice little bar, bright pink. Isn't that fun? All right. And we're going to divide it into 4ths. Okay. And then we're going to further subdivide it into 8ths. All right. But we are also going to shade, let's shade 3/4 of it. Our original markers for the 4ths were here. 3/4 would go up to this much of the figure. So let's go ahead and shade that. And I think you can still see the dots for the 8ths underneath it. All right. So each of these pieces being 1/4 shaded, right? And there are 3/4, comes up this far. And And the question is, how many 3/8 are in this? Well, here's 1, 2, 3. That's 3/8. And 1, 2, 3. Look, here is 1 3/8. And here is another 3/8. So we see that there are 2 3/8 in 3/4. All right, we see it by the drawing. But how does it look? How does it look with our procedural, right? Well, we take our 3/4 and we are dividing it by 3/8. In this case, we want to multiply it by the reciprocal, inverse operation, with an inverse fraction, right? So that would be 8/3. And there is a lot of simplification that can go on here. Let's see, 3 goes into 1 once, goes into itself 1 time. 4 goes into itself once, and it goes into 8 twice. So our new problem is basically 1 over 1 times 2 over 1, which is 2. Didn't even have to do all that. You guys could see that. 1 times 2 is 2. And 1 times 1 is 1. All right. So our answer to our problem is 2. Well, what does that look like in our complex fraction? I want you guys to see this because this looks so hairy. Oh my goodness. Let's go back to our original color that we were using on the previous slides. 3/4 divided by 3/8. Oh my gosh, so complicated. We're going to multiply by our reciprocal to get ourselves 1, okay? This becomes 24 24ths, and that is 1, okay? So, but we cannot do this just to one, the denominator. We also have to do it to the numerator. Whatever we do to the bottom, got to do this to the top. So we're multiplying the top by 8 over 3, just like we did to the bottom. And if we multiply across, we get 24. This is without simplification, 12ths. And 12 goes into 24 twice. So our answer is 2 over 1, but it's 2. All right. Yeah, that worked out great. All right. Let's see if we can do one more example. Let's do a fun real world problem here. Let's see what we got. Oops. On page 71 in your book, B, you have a fun problem which says a plank is 4/5 of a meter long. So there's a wooden plank. I'm just going to draw a picture. And this plank is 4/5 of a meter long. Let's see. So let's just cut it into fifths so we can see this easily. And we know we don't have the whole thing. We only have part of it. So let's do it with a contrasting color. We only have 4/5 of it. All right. So the plank is 4/5 of a meter long. And let's see. A worker cuts it into some pieces, each of which is 1/10 of a meter. So basically, this plank is going to get subdivided here. Let's find an even funner, if that's a word. I'll do white. Why not? We're going to divide this into 1/10 size pieces, right? So now each of these 1/5 size pieces are in half. And once the worker does that, we're asked, how many pieces did he cut the plank into? Okay, so the problem is, how many 1/10ths are in 4/5? And by looking at it, you can see 1, 2, 3, 4, 5, 6, 7, 8. There are 8 1/10 size pieces in 4/5. Now, if you do it procedurally, and believe me, you're going to have to do some of these procedurally, which is why we're practicing them. 4/5, use the inverse operation with the reciprocal, which is the inverted fraction, okay? And that becomes 40/5, which is 8, okay? Now, I could always have simplified this, and let me do that for you. Let me show you. 5 goes into itself once, and it goes into 10 twice. And if I multiply across numerator and denominator, I get 4 times 2 is 8, and 1 times 1 is 1, and that would be 8/1. Which would also be 8. Okay, so that's what it looks like if I do the, my rule that I can, anything, whenever I divide by a fraction, I can multiply by the reciprocal instead. What does that look like? Well, 4/5 is being divided by 1/10, and this is a complex fraction, so we want to get rid of that fraction in the bottom. We turn it into 1, and whatever we do to the bottom, we have to do to the top, and so we wind up with a new problem, which is 40/5, because I multiplied across, right? 4 times 10 being 40, 5 times 1 being 5, and that's 8. Okay, 3 ways to do the same problem. I've done a lot of these for you. Let's see if we can find another one. Okay. Let's do number 22 on page 73. So 22 on page 73 says 5/8 divided by 15/16. So what's the first thing I do? This is a really hairy problem, because this is almost 15/16 is almost 1. It's very close to 16/16, which is 1. So it's essentially asking you how many 15/16 are in 5/8. And the drawing for this is going to be so complicated, I don't even want to go there. I have no desire to do the drawing for this picture, or the picture for this problem. I don't know about you. So I'm going to apply what I know, that I can take my fraction that I'm dividing, and instead of dividing, I'm going to multiply an inverse operation by the inverted fraction, 16/15. And you know what? This is a very clean little problem, because I see a lot of ways I can simplify, and I'm going to do that right now. I'm going to change pens here so you can see what I'm doing. 5 goes into itself once, it goes into 15 3 times. 8 goes into itself once, and it goes into 16 twice. And so the new problem is 1 times 2, which is 2, and 1 times 3, which is 3. And that makes sense, because that 2/3 is the answer, because we asked, well, about how many, if 15/16 is almost 1, about how many 1s are in 5/8, which is around half. So there would be 2/3 of a 15/16 and 5/8. That makes sense to me, right? Because 5/8 is a little more than 1, and 15/16 is a little less than 1. So that's a reasonable answer. I think it makes sense that there would be only about 2/3 of 1. All right. What does this look like if we do it the long way? Well, 5/8 divided by 15/16, complex fraction, want to get rid of it, don't want it around. I'm going to turn this into a 1, and I'm going to multiply up here by the reciprocal. And of course, I'm able to simplify. And I'm going to simplify because I don't want that hairy problem staring me in the face. And I get the same thing, 2/3. All right. Guys, I think you get the hang of it, don't you? Let me see if there's one more that might trip you up. Oh, what about if we divided a fraction by an improper fraction? I tell you what, come back for that in the next video.